In this video, we're going to talk about discrete random variables. So random variable is a numerical measure of the outcome of a probability experiment. So suppose you flip a coin 3 times. Let x represent the number of heads that occurs in this experiment. Well, what could x equal? Well, you could flip the coin 3 times and get no heads. You could get it as 1 head and 2 tails, 2 heads and a tail, or 3 heads and 0 tails. So here, little x could equal 0, 1, 2, or 3. All right, how about an experiment is conducted to determine the time in hours t it takes for a light bulb to burn out? How do you write t out? Well, obviously it's not going to be negative hours, but you could open a package with a light bulb and it doesn't work at all, so it burns out immediately, or 0 hours. So it could be, or anything greater. So here, this would be t is greater than or equal to 0. So there's 2 types of random variables. One is a discrete random variable, and the other is a continuous random variable. So a discrete random variable is a variable that has a finite or countable number of values. So again, when I draw this on a number line, I could be 0 or 1 or 2 or 3 or 4, but I can't be anything in between. Well, the example of flipping the coin 3 times, that was an example of a discrete random variable, which is what we'll talk about more in this section. The continuous random variable is a variable that has infinitely many values. So it could be 0 or 1 or 2 or 3 or 4, but it could be any particular value that is in between also, any fraction, any decimal. So the light bulb experiment is an example of a continuous random variable. Okay, let's take a look at these 2 examples to determine if the random variable is discrete or continuous. So the number of cars in the Hack parking lot from 8 a.m. to 9 a.m. Well, you can literally count them, such as 4 or 5. You're not going to have half a car or a third of a car. So this is an example of being discrete. Weighing every baby in pounds that is born in York on October 1st. Sure, you can have half a pound, a third of a pound, so on and so forth. So this would be an example of being continuous. So again, we will focus on discrete random variables in this section. Okay, so a discrete probability distribution provides the possible values of the random variable and their corresponding probabilities. So let's take a look at an example. The Baseball World Series is played by the winner of the National League and that of the American League. The first team to win 4 games wins the World Series. In other words, the series will consist of 4 to 7 games, depending on the individual victories. The data below shows the 40 World Series events. So x equal to 4, that means 8 World Series events took exactly 4 games. This is saying 5 games and 7 of the World Series out of the 40 played 5 games. Okay, so now let's construct a discrete probability distribution. So with 4 games, we know it's 8, and we're picking 40 total World Series events. That simplifies to 1/5, and that decimal is 2/10. So for 5 games, that's 7 out of 40. And that decimal is 0.175. 6 games, it's 9 out of 40. That's the same as 0.225. And for 7 games, that's 16 out of 40. That simplifies to 2/5, which of course I could write as 4/10. So there's my discrete probability distribution. Now, for part B, let's graph the discrete probability distribution with this information. So I have the beginnings of this sketched out. The horizontal axes we'll label as number of games played. The vertical axes we'll call probability, and we'll give it a title of the number of games played in each of the 40 World Series. Now, for the horizontal, we know it's going to be what? 4, 5, 6, and 7 games. The least probability was 0.175, and the greatest was 4/10. So I'm going to go by 1/10 for this. So the 4 games was 2/10, so I'm going to draw a dot and draw a line segment coming straight down. For 5 games, that was 0.175, so that's a little bit closer to 2/10 than to 1/10. So I'll put that dot here, draw the line segment straight down. 6 games, that was 0.225, so that's a little bit above 2/10. Put a dot, draw the line segment coming down. And then 7 was 4/10, so put the dot there. Okay. So it looks like with the graph that we certainly have more 6 and 7 game World Series events than 4 and 5. So clearly the distribution is going to be skewed left. So how would I describe the distribution? Skewed left. And this means, in this case, there are more 6 or 7 games being played in each World Series event than just 4 or 5 games. Okay, so discrete probability distributions have to follow the rules for probability. So that P of x denote the probability that the random variable capital X equals little x. Then, remember this symbol. That's the summation notation, meaning sum. So the sum of all the different probabilities should add up to equal 1. And each probability should be in between 0 and 1. Yes, it can be 0. Yes, it can be 1. Or it can be somewhere in between. Okay, let's take a look at a couple of examples to determine if each of these are discrete probability distributions and justify your position. So let's start with a left example. Add up the probabilities. 5/10 plus 3/10 plus 2/10 plus 1/10 is 1 and 1/10. Well, certainly that is not equal to 1, so this is not a discrete probability distribution. So let me write this out now. Okay, so since the sum of the probabilities equal 1 and 1/10 and not 1, this is not a discrete probability distribution. Okay, let's take a look at the right example. So again, the first thing I would do is I would add up the probabilities. So 2500s plus 2/10 plus 3/10 plus 2500s, that does equal 1. Now, take a look at each probability. Are they in between 0 and 1 inclusive? 0.25, yes. 0.2, yes. 0.3, yes. 0.25, yes. So this is going to be a discrete probability distribution. So let me write this out now. So since the sum of the probabilities does equal 1 and each probability is in between 0 and 1, this is a discrete probability distribution.